Alright, and now that we correctly handle the pull up or pull down resistor when we actually initialize the button, so here we initialize and we already have the parameters here, what we can do is also improve the way that we read the state from the button, okay? Because we are creating a class, we can add much more abstraction. Here what we do with the read state function is, well, we simply get the state of the pin for the button, which doesn't necessarily mean anything. Okay, we get high or low, and depending on if it's pull up or pull down, well, we need to actually check what's the meaning of the states directly in the loop. What if we directly want to check a function that tells us button dot is priced, and that automatically handles the pull up or pull down behavior? So this is an abstraction that we are going to add to the class of the push button. And I'm going to add this here. Bool is pressed, like this. So I add a new declaration, and I'm going to modify the behavior also of the read state function. So bool is pressed. I'm going to add a new function here. So when you add a new, as you can see, a new method or a new function, you just add the declaration here, and then you add the implementation in the C++ file. Bool and then push button is priced, and then we are simply going to return true if the button is priced and false if the button is not priced, which makes much more sense, okay, than just returning the state, which would be either high or low depending on the pull up or pull down resistor. So we are going to put all of this logic inside the class, so we don't need to worry about that anymore outside of the class. So when we call the function is priced, what I'm going to do is first to call read state. So I call the read state function here. That is going to update the state attribute. It returns the state now, but we are not going to use this. So we just update the state, which we can get here as a private attribute. So first update the state, and then we are going to check if is pull up. Okay, so we have the is pull up here, the boolean here as a private attribute that we can use in our method. So if this is a pull up resistor, we are going to do something, and else we are going to do something else. So if we have a pull up resistor, we return state is equal to low. So basically, with a pull up resistor, the default state of the button will be high. When you press on the button, the state will be low. So if this is a pull up and the state is low, then that is going to return true. If it's not a pull up, then it's a pull down. In this case, the default state will be low, and we're going to do return state is equal to high. So the button will be pressed when the state is high. Okay, so with this, we can do all of the logic with the pull up or pull down resistor inside this method, so we don't need to worry about this anymore outside when we call is priced. As long as we put the correct values here when we call the constructor of the class, then everything else will be okay. And now the thing is that I don't want the read state function to be available anymore from the outside of the class, okay? Let's say I just want to use it as an internal purpose, and then the only available interface to get the state of the button is priced. So what I'm going to do, I'm going to modify two things. First, I'm going to do here void, and I'm not going to return any state. Why is that? Because, well, simply the state here is available because this is a private attribute, so any other method can just call this function and then get the state without having to get the state from a return statement, okay? And then I'm going to, so here I'm going to do void also, and I'm going to put this method here in the private section of the class. So now it is not possible to call this outside of the class. So the only interface we have now is so the constructor init and is priced. So as you can see here, not only attributes can be private, you can have functions our methods that are private. So let's go back to now our example when we call the class, when we create an instance of a class with this object, the button object. Let's actually see what we get if we verify the code like this. You can see void push button read state is private within this context. So now we can't use read state anymore. Okay, I'm going to remove this and I'm going to do if button dot is pressed, and let's say serial dot println button is pressed, and then else, so if it's not pressed, serial.println button is not pressed. And so we can do different actions depending on that. Let's now verify the code. And it's working. So now, as you can see, it makes much more sense. We have a button object, okay, we call init in the setup. And then what we want to get as a value from the button is simply that is the button is priced or not. Well, now we have if button is priced, and this makes much more sense than actually use digital write in the loop or to get the state and to have to actually compare the state with high, low, and make all sorts of logic to know if the button is priced or not. Here we just call button is priced, that's it. You can see the interface here is very straightforward. Constructor init is priced. All the implementation is hidden here in the implementation file. All right, so now let's check board is connected. If I upload the code and let's open a serial monitor, you can see button is not priced. I press on the button, button is priced. I release the button, button is not priced. Okay. So that's a great step for the future of the project. Now we have more context on the push button. And with just 1, 2, 3 lines, we have everything we need in the main file.